more on convergent plate boundaries. Now let's talk about what happens when two plates of oceanic lithosphere come together. We can see this all over the globe, and one place that's really famous is this name that most people have heard about, the Ring of Fire. So the Ring of Fire was called that because of sailors were somewhere out in the Pacific. More than likely, wherever they landed, there was going to be some volcanoes around, just because of how prevalent this oceanic lithosphere convergence is. And we can see that's happening in places like the Aleutian Islands, Japan, Indonesia, New Zealand, all of these places in the Pacific Ocean. Actually, on the eastern side, a lot more of these are oceanic continental volcanic arcs, like this one in the Andes Mountains in South America, and the mountains in Oregon and Washington State, the Cascade Range. But let's talk about this other side now, where the Ring of Fire completes its ring and is more about the oceanic convergence. When two pieces of oceanic lithosphere come together, what typically happens is the older and denser piece of oceanic lithosphere starts getting subducted or going beneath the piece of younger or more buoyant oceanic lithosphere. And as this happens, we get a trench, just like we have with oceanic continental plate convergence. But now we also get this volcanic arc being built, but now the volcanic arc is not being built on a continent like before. It's just being built in the ocean. It's a series of islands that appear as volcanoes and occur in the ocean. So that's what causes this volcanic arc to be formed. There was just previously oceanic material here, but once this subduction takes place, there's partial melting at the top of the lithospheric plate. That magma moves through the asthenosphere, the lithosphere, the crust, and finally forms these volcanoes right at the top of the ocean floor. Sometimes these volcanoes poke through the oceans, other times they don't. There might be some here that don't, but overall they form a linear pattern or an arcuate pattern on maps and globes, and so it's called a volcanic island arc. Here's another example with the Aleutian Islands. Alaska is up here, and this is part of the state of Alaska, the Aleutian Islands, but it's this sort of volcanic island arc. So the Pacific plate here is being subducted to the north underneath this plate here, and it's first creating a trench to the south, and then where the volcanoes associated with the melting of the top part of that lithosphere occurs is to the north of that, and that's what's creating this Aleutian trench, and also with a very arcuate shape, because that's just when you have two plates on a globe and they interact with each other. That's just the sort of patterns that you get. And probably the most famous example of a trench, because it's the deepest spot on Earth, is the Mariana Trench, which is near Guam. The Mariana Trench is on this side. We can see that subduction, once again, here would be this oceanic lithospheric plate is getting subducted underneath the oceanic lithospheric plate to the west. So we first get the trench, and then we get the volcanic arc, the volcanic island arc on the west side of that. And the Marianas Trench, once again, is the deepest place on Earth. And you can kind of see here by comparison, it would be much deeper to go down into the trench than it would be to climb to the top of Mount Everest. When oceanic material is subducted underneath other oceanic material, we get these island arcs being formed. But those island arcs don't always stay in the same place. In this example here, we had an island arc formed because this oceanic lithosphere was getting subducted under this oceanic lithosphere, and we got this island arc developed. However, in the future, this oceanic lithosphere started getting subducted underneath a continent. It formed a continental volcanic arc here, but also it started the conveyor belt motion of this island arc towards the continent. This has happened a lot in the past, and these little volcanic island arcs get accreted or added onto the side of continents. So as you can see over time here, this subduction stops, but this subduction picks up. This old island arc is going to move towards the continent, which is exactly what's happening here. And eventually, as this oceanic plate gets subducted, this old volcanic island arc is just going to get accreted or added to the side of the continent here. And that has happened over and over again on the western side of the United States. In Central Oregon, we're living on top of old volcanic island arc. And it creates quite a puzzle for geologists to solve.